So, I saw this lecture by Francis Sue tonight, and he asked an interesting question. Is it possible to have an irrational number, I'll call it A, to an irrational power equal a rational number? So irrational number A to an irrational power B, irrational number. So what's an irrational, what's an example of an irrational number?
The square root of 2.
Square root of 2 is irrational.
Or pi.
Pi.
Or decimals?
Decimals can be irrational, and sometimes they're rational too. But pi is a good example. So is pi to the pi possibly a rational number?
Well, that means you have pi. Well,
Pi times.
pi times.
That's a lot of pi.
Yeah, it's hard to understand even what it means, right? Because how can you have pi copies of pi? We understand what it means to have 3 copies of it.
Yeah.
Right?
Or the square root of 2 copies of pi.
Yeah. So square root of 2 is actually an interesting one because square root of 2 is the opposite of this. Do you know what power the square root of 2 is? It's 2 to some power.
Is it a 2 to the 1/2?
Yeah, 2 to the 1/2. So this is an irrational number, right?
Yeah.
But this is a rational number to a rational power.
Because it's an irrational number.
But it makes an irrational number.
And does it work the other way?
So is there an example that works the other way around? And there's an incredibly cool proof, and by coincidence, and it actually involves the square root of 2. And I want to, before jumping into this proof, I want to show you, or not show you, I want to tell you something. And this is a fascinating example of a mathematical proof because we're not going to know what the numbers are that work. We're just going to know that some number works.
Maybe we can figure it out.
Yeah. So this is a very interesting example. So he says, let's consider this number, square root of 2 to the square root of 2 power. Okay? And is this rational or is it irrational? Do you know? Do you know about the square root of 2 to the square root of 2?
Well, it was in the x to the x to the x to the x thing.
Oh, very good memory. Except that one went all the way up forever. Right? Here we just have the square root of 2 to the square root of 2, only one level high. So do you know what this number is?
No.
Do you know if it's rational?
I don't think it's rational.
Do you know if it's irrational?
No.
Okay. What would it mean if it was rational? If it turned out it was rational?
Then this proof would work.
Then we'd be done, right?
Yeah.
So if it's rational, we're done. We don't have to go anymore. But if it's irrational, what do we have to do?
We have to try another number.
We have to try another number, okay? And then this is where he shows an amazing thing. We're just going to take whatever this number is, we're going to assume it's irrational. Because if it's rational, we're done. So let's just assume it's irrational, and we'll raise it, this number, to the square root of 2 power. Now what happens when you raise powers to powers?
Well, then it multiplies.
So I have to take the square root of 2 times what?
But then
Times whatever this is.
Well, how do the powers work?
So it's the square root of 2. So it's just this. It's square root of 2 squared.
Okay, which is what?
Which is, it's 2.
Okay, so this equals the square root of 2 squared. Which is what?
2.
Is that rational or irrational?
It's rational.
That's rational. So if this number was irrational, here, square root of 2 to the square root of 2, we just raise it to the square root of 2 power, which itself is irrational,
Yeah.
and we get a rational number. So we found one of these two numbers is rational. Either the square root of 2 to the square root of 2 to the square root of 2 power is rational, or, either this is an irrational number to an irrational power that is a rational number, or this is rational all by itself. Maybe that's rational. We don't know. But either way, we found,
It's rational.
what did we find?
We found irrational powers added up to the rational number.
Yeah,
And it works.
cool. So you can have an irrational number to an irrational power,
Cool.
making a rational
Well,
number.
you could also do this for like root 3s. You could have root 3 to the root 3 to the root 3. You'd have to have an extra root 3 because you need No wait, you wouldn't have to have an
Ah.
extra root 3.
Let's see. Let's see. That's a fantastic observation. High five. Let's see what happens with root 3.
Alright.